Hello everyone. Today's topic is linear inference and multivariate analysis. Partial correlation. Partial correlation is a device to study the relationship between dependent variables and one of the independent variables by excluding the effect of other variables, that is, keeping the other variables constant. Partial correlation is also called net correlation. It is a study of the relationship between one dependent variable and one independent variable by keeping the other independent variables constant. In simple correlation, the effect of these other independent variables was ignored. Zero order coefficient. Simple correlation between two variables is called zero order coefficient, as in simple correlation no factor is held constant. Next, first order coefficient. A partial correlation between two variables keeping the third variable constant is called first order coefficient, or one variable kept constant. Second order coefficient. A partial correlation between two variables keeping two other variables constant is called second order coefficient. Next, partial correlation coefficient of three variables. Let x1, x2, x3 be the three variables. R12 is equal to simple correlation between x1 and x2. R23 is relation between x2 and x3. R31 is simple correlation between x3 and x1. These three are all zero order coefficient. R12.3 is partial correlation between x1 and x2 keeping x3 constant. R23.1 is partial correlation between x2 and x3 keeping x1 constant, and R13.2 is partial correlation between x1 and x3 keeping x2 constant. All these three are first order coefficient. Partial correlation coefficient in three variables. R12.3 is equal to R12 minus R13 R23 divided by root under 1 minus R13 square into root under 1 minus R23 square. Similarly, R13.2 is equal to R13 minus R12 R23 divided by root under 1 minus R12 square into root under 1 minus R23 square, and R23.1 is equal to R23 minus R12 R13 divided by root under 1 minus R12 square into root under 1 minus R13 square. The next topic is partial correlation coefficient in 4 variables. This is a second order partial correlation coefficient as 2 variables have to be kept constant. There would be in all 6 partial correlation coefficients of second order: R12.34, R13.24, R14.23, R23.14, R24.13 and R34.12. The formula for the এটা 6 মিনিট হয়েছে। Again, R14.23 is equal to R14.3 minus R12.3 R24.3 divided by root under 1 minus R square 12.3 into 1 minus R square 24.3 root under. Similarly, the other 3 can be derived in the same manner as the above correlations. Limitations of partial correlation analysis. In the calculation of partial correlation coefficient, it is preassumed that there should exist a linear relation between variables. Hence, I repeat again, linear relation between variables is preassumed. In real situation, this condition lacks in some cases. Number 2, the independent variables in the study of partial correlation should be linearly independent. This is another limitation where in the study of partial correlation, the independent variables, they should be linearly independent. Number 3, the reliability of the partial correlation coefficient decreases as their order goes up. This means that the second order partial coefficients are not as dependable as the first ones. Therefore, it is necessary that the size of the items in the gross correlation should be large. So, size should be large. I repeat the third point again. The reliability of the partial correlation coefficient decreases as their order goes up. This means that the second order partial coefficients are not as dependable as the first ones are. Therefore, it is necessary that the size of the items in the gross correlation should be very large. And number 4, the last limitation. It involves a lot of calculation work and its analysis is not easy. Hence, these are the 4 limitations of partial correlation analysis. Thank you.